Hey everybody, just want to welcome you to week 6, module 6 for ME14 Mechanics of Solids course. Within this module here, we're going to be taking a look at chapter 4 in our textbook, Pure Bending. And within this, we're going to take a look at a couple different topics here. We'll look at the principles of bending behavior, pure bending in beams, where we're looking at deformations, strains, and normal stresses. Then we'll take a look at some different types of composite beams and how we apply some of that governing theory and equations to those. Then we'll look at those for stress concentrations, plastic deformations, and we'll look at some elastoplastic material as well. Then we'll go ahead and look at some eccentric axial loading or stresses from axial and bending. And then from there we'll go on to unsymmetric loading and some bending of curved members. Now, a couple bookkeeping items for this module here. You do have your quiz number 6. This is posted on Monday and it'll be due on Friday the 12th by 4 p.m. And as a reminder, as always, I do have office hours scheduled on Wednesdays from 9:30 a.m. till 10:30 a.m. If this time doesn't work for you, please let me know. Send me a chat or a message. I also have open office hours Monday mornings as well from 9 a.m. till 10 a.m. You're welcome to jump in on those. And again, if none of those times work for you, please send me a message or an email or chat, and we'll find a time that does work. So now as we jump into Module 6, we're going to be taking a look at our Chapter 4 in our textbook here. So within this module, we're going to analyze the stresses and strains in prismatic members subjected to bending. So again, we're talking about pure bending right now. Bending is a major concept used in the design of many machine and structural components, such as beams and girders. So this is going to be extremely important to understand how we can do these tests and analysis of these different members for those applications. Now, this module is going to be devoted to the analysis of prismatic members subjected to equal and opposite couples acting on the same longitudinal plane. So that'll simplify it down a bit for these particular cases right here. So some objectives for this module here, we're going to consider the general principles of bending behavior. Then we're also going to define deformations, strains, normal stresses, and beams that are subject to this pure bending. From there, we're also going to describe the behavior of composite beams made of more than one material. So that's what we're going to take a look at, and that's the reality, a little bit more practical application there. It's not always just going to be one type of material, so we'll talk about these composites. From there, we're going to review stress concentrations and how they are included in the design of beams. Then we'll study the plastic deformations, and with that, we're going to determine how to evaluate beams made of elastoplastic materials. Then we're going to analyze the members subject to eccentric axial loading involving both axial stresses and bending stresses. We'll take a look at our governing equations behind that. We'll review beams subject to unsymmetric bending as well, not just symmetric, but now we'll take a look at unsymmetric. And this is where the bending does not occur in a plane of symmetry. So we'll see how that affects our results and our calculations. And last, we're going to take a look at bending for some curved members as well. Now, as this relates back to our textbook, your reading guide for Chapter 4 is going to be Chapter 4, Sections 1 through 5, and then Chapters 4, Sections 6 through 10 for Modules 6.1 and 6.2. So we're going to break this down into two sections within Module 6. So for Module 6.1, again, we're still looking at pure bending in Chapter 4 of our text. We're going to concentrate now on deformations, composite materials, and stress concentrations. So objectives in this is to consider the general principles of our bending behavior, define these deformations, strains, and normal stresses and beams that are subject to pure bending, go through that behavior of the composite material beams that have more than one material again, and then review those stress concentrations and how they're going to be included in the design of beams. So we're going to focus on these four objectives for Module 6.1. Now, as we're looking at these, we're going to talk about the theory, some of our key equations, how we apply this to specific cases, and from there go through some actual problem solving and solutions. Next, we're going to move on to Module 6.2. In Module 6.2, still looking at pure bending, but now getting some plastic deformations, eccentric axial loading, some more composite materials, and stress concentrations. So what we'll take a look at here is, again, we'll go through what is a plastic deformation, how does that apply, when do we look at these elastoplastic materials, how does that affect our bending, how does that affect our solution to these problems here. Take a look at eccentric loading, so this axial loading there, and with the associated stresses for axial and bending. And last, we'll take a look at the unsymmetric bending and also look at the bending of curved members. So this is the four topics that we're going to concentrate on for Module 6.2 here. And again, go through the theory behind all of these, talk about our governing equations, see some practical applications, and then apply that to some actual problem solving going through the solutions.